Hi everyone, I'm Dr. Longituda and my twin sister. And I'm doing a review for the Chem 4 final. The first thing I want to do is apologize for three things. Number one, the lack of examples, because we have so much material to cover. I'm not going to be able to do nearly as many examples as I want, but I want to do make sure you get the concepts of the problem and highlight those. So we'll do key examples. Number two, if you see any math errors, just fix them, because we're going quickly, and so I'm more than likely going to have math errors. Don't get alarmed. The important thing, again, is that you understand the concept of how to do the problem. And number three, the speed. Normally I don't move this quickly, but since we have to get you ready for the final, I'm moving more quickly than usual. And if you find that it was difficult to catch the first time, you can always watch the video again. So, I'm going to start with significant figures. I know this is Chem 3 stuff, but you don't want to get all the way through a problem and get the right answer and have the wrong significant figures, because you'll lose part, most, or all of the credit, depending on who your teacher is. So let's start with reviewing the rules for significant figures. And there are really only two rules. It depends on whether you have a number that has a decimal or a number that doesn't have a decimal. If your number has a decimal, the difference in figuring out the number of significant figures is where you start counting. First of all, always count from right to left. It doesn't matter decimal or not decimal. Number two, in both situations, decimal or not, you're always going to end on the last number that's not a zero, the last non-zero number. So let's look at two examples. Here's a number with a decimal. This is where the difference lies between these two. The difference is where you start counting. With a decimal number, it doesn't matter whether this is a zero or a number. You start at the end of the number. You start counting significant figures there. And we're going to go all the way, continue left, from right to left, until we get to the last non-zero number. So 1, 2, 3, 4, 5, 6. This number has 6 significant figures. Now let's look at a number that has no decimal. For example, 250. If we were counting something like dogs or cats, 250 is 250, and there are 3 significant figures. But you're not going to see this in chemistry. Dogs and cats, anyway. So let's look at this. The difference between a decimal and a not decimal is we're not going to start on the right if it's a 0. You have to start on the first non-zero number. So in the no decimal number, we're starting on the 5. Both of these are going to end on the left with the last non-zero. So we're going to end here, and we're going to end here. So in this example, how many significant figures do we have? We're starting on the first non-zero. So 1, 2. 2 significant figures. Let's look at another example with a decimal. Doesn't matter, you start on the right always. You're always going to start on the right, decimal or not. With a decimal, you start on the right, whether it's a 0 or a number, that's where you start. So we have 1, 2, 3. Since these are zeros and not non-zeros, they don't count, because you always, in both cases, end on the last non-zero number. So this number has 3 significant figures. Again, here's another example with a non-zero. Here's the difference between decimal and no decimal. We can't start on that 0. We have to start with the first non-zero on the right. So we have 1, 2, 3. 3 significant figures. The reason you need to know significant figures is when you get to the answer, you can't include all the numbers that the calculator is going to give you, because you know calculators go crazy and they'll give you 10,000 numbers. So you're going to look at the number of significant figures in the problem to figure out how many to include in your answer. Now, if you're multiplying or dividing, I want you to look at the problem, the question they give you. and find the number with the least number of significant figures. The least number of significant figures. That's the number of significant figures in your answer. For example, and we'll do molarity in a little while. If they ask you, what's the molarity if you have 10 moles in 3.5 liters of solution? They give you that information in the problem. And we want to know, now when we divide that, we get 2.857142857. Well, write moles per liter. We'll write that down on the test, and you'll be surprised how many points you lose. We can't use all of these numbers, so let's go back to the information they gave us. They gave us this. Here's our decimal. We're going to start on the right, 0 or not. 1, 2, 3, 4. 4 significant figures. Look at the other number they gave us. 1, 2. 2 significant figures. Which one are we going to use? The least number of significant figures. So we need to get this number down to 2 significant figures. 2.857142857 moles per liter. We need 2 significant figures. Go to the left, underline the 2 significant figures. If the number following the last significant figure is 5 or greater, round the last significant figure up. This number after our last significant figure, because we only need 2, is 5 or greater. So this is going to round up that 8. That makes our answer 2.9 moles per liter. That has 2 significant figures. Okay, good. Now there's another set of rules for if you're adding or dividing, but 99% of the time in Chem 3 and 4 we're only multiplying and dividing, so you don't really have to worry about that. So I'm not going to cover it because I don't want to waste time. Time? Time? Danny? Time. 54. Now we're 55. 1 more minute. Oh, all right. So we're going to cut here. We're going to cut here, and we're going to start with, we're going to continue with video number 2. We're going to cover 2 life-saving equations that will get you all the way through the course. Whenever you're stuck, odds are you're going to use one or both of the life-saving equations. So I'm going to cut here.